great. Okay, so we're going to talk about how to get things set up for table calculations today. I'll turn that one off. So first of all, I just want to start out with some appreciations. So number one is Ross Bunker. He's the guy who wrote table calculations in the first place for Tableau, and the help he's given us on the Tableau forums and through some emails here and there has just been incredibly useful. Number two on the list is the legend, Joe Mako. We wouldn't be where we are in understanding Tableau without him, and for me personally, I still learn new things from Joe on a regular basis, including just yesterday. When I was first learning table calculations, I came into Tableau at a really nice time with version 6.1 when custom table calculations were first there, and the data source I had to use was Microsoft Access in my work, which couldn't really do a whole lot. So he was somebody who was working with table calculations on, and I learned from him, and the same thing for Richard Leak as well. And then somebody else who inspired me to start blogging and do really great stuff and can be a very snappy dresser, Mr. Andy Cotgreave. And then one more person who talked me into doing this Think Data Thursday is Sean Walwork from the Tableau forum. So thank you all. And I also appreciate my employer, Southern Maine Healthcare. A little shout out to them for giving me time to be able to do this kind of thing. And then also my wife for supporting my Tableau addiction. So with that, what we're going to talk about today is how to work with table calculations, and it really requires thinking about Tableau a little differently. So we each come to Tableau with our own mental models of data and data visualization, and then we're using this lovely software application that really has a lot of overlap with our mental models, and that's why it works so well for us, but it's not complete, particularly in the area of table calculations. So what I'm going to try to do today is help extend your mental models a little bit. So the first area here is two different ways of working with Tableau. So there's exploration and composition. So the kind of default way we start out with Tableau is we see our dimensions and measures on here over the left, and then the interface is encouraging us to start double-clicking, clicking and dragging. Maybe we're clicking on the Show Me button, and we're seeing our data. It's appearing right there. Then we're doing something else. We're seeing our data again. It's really great for that. But if we want to do certain kinds of views and certain ways of doing things, something like this maybe, where there's 16 levels of nested table calculations in this, there's no way you're going to get there by clicking and dragging. So you need a different way of working. And the same thing goes with this horizon chart by Joe Mako, or this fractal fern by Noah Salvatierra that starts with only 2 rows of data, and then it's plotting thousands and thousands of points here. So the last 3 visualizations I showed you are more like a piece of music, even a piece of symphonic music, such as this one, Eine kleine Nachtmusik, where all these pieces parts are put together to create a cohesive, integrated piece of music or a visualization. Now, one thing people ask for is, what's the recipe? What's the trick for getting table calculations to work? I'm going to give you some good news and some bad news. So we'll do the bad news first. So I've identified 22 different factors that influence what you see in a Tableau visualization that doesn't even use table calculations. I'm still going here. So the granularity of the data, what version of Tableau you're on, is your data sparse or complete, what your mark type is, all sorts of things like that. And then there's an additional 9 factors that are really specific to table calculations. So we're going to come back to this. So one way of looking at this is that the number of all these factors and all their interrelationships and all the combinations of data we work with and visualizations we create is like the number of stars in the sky. So it's a huge amount of potential combinations, and then with that, this is where switching in between is hard because I have to go in and out of presentation mode. can create visualizations like this one, or this one, or this one. Just like in music, we can put things together and end up with a piece like this. And we're formatting pictures again, or this. So a lot of variation here. So my impression is that many, if not most Tableau users are not aware of all these different factors and how they relate. So the good news is that we can learn what these factors are, and it's like teaching music theory. However, we've only got about another 45 minutes here, so I'm going to give you touch on a few of these factors, and then also give you a process for working with the table calculations so you can be more certain to end up with your desired results. And if you're not getting there, you can know exactly where things went off the rails and then be better prepared to identify and figure out what's going on your own, or be able to go out and ask for help on that. So here's the process. So step one is understand your goal. What is it you're trying to do with this visualization here? Because we're in a composed viz, not an exploratory viz. Understand your data. If you're not understanding what's going on in your data, the structure of your data, what the relationships are between the different parts of your data, it's going to be really hard to arrange for good results later. And then figuring out what that ideal data and structure and values, given your understanding what Tableau works, would look like to reach that goal. And in the case of Tableau, there can be a lot of different ways we can get to a goal, and we may use different ways depending on our knowledge level. So there's no one ideal right way here. And then once we've gotten that sense of how things need to be, then we're going to figure out the calculated fields, the dimensions, the measures, restructuring our data that are going to get us back towards that goal. And then finally, we're building the view, and we're dragging and dropping pills, and at that point, we're back into that wizzy drag and drop experience that we had really early on. However, when we're working with table calculations, it gets a little more complicated here. So this step, I divide the creating the final view into two parts. So one step is building a workout view in the form of a crosstab. And in that process, we're going to be careful to verify each step because there are many things that can go off the rails with table calculations. And then once we're done with that, we duplicate that view to drag and drop pills. So whereas in Tableau, we might start dragging something and boom, we have a line chart. When we're doing more complex stuff with table calculations, we're going to slow things down a bit and do them one part at a time. Just like with that piece of music, like a symphonic piece of music, where the composer is creating just a few notes at a time that add up to be that symphony. So the first part here, understanding the goal. So I have a great example from the last 24 hours here from the website where here's somebody, and I'm not blaming this person, this is just kind of not being familiar with what to do or how to work with Tableau or how to ask questions in the forums. This is what they're doing. So this person saying, I've got this formula written here, the formula is working fine, but I'd like to see the view in a pie chart with only two parts, comparable sales versus non-comparable sales. There's no discussion of what comparable sales versus non-comparable sales are, what dimensions are in the view, any of these different things. And then there's all this text here where people are trying stuff out. There's back and forth saying, well, that didn't work for me, that kind of thing, going on and on and on. And this problem still isn't solved after something like 10 different forum posts here. So to speed that up, we want to really understand the goal. So one way to do that is to write out your specific goal. So for example, do you want a bar chart with the average number of appointments at 8 a.m. on a Monday? Or is it a bar chart for each hour in a workday, showing the average number of appointments, and then also counting days with no data? So you're talking about your sparse data as well. So being really clear about that written. That may not be the way things work for you. Maybe you're saying, okay, I'll need a picture of it. So draw a picture of what you want. Maybe you're marking it up in Excel, maybe it's on paper, or PowerPoint or Word or something, just doing that. Another piece of it is thinking about what don't you need. So you have this huge range of data. Maybe you don't need certain years, certain elements of your data in that. So what are you going to be filtering out? Also, another piece of this is thinking about what kinds of interactions you want to enable in the data. because of all those different factors, knowing what kinds of interactions are here are part of it. So in this particular visualization, we're clicking on a bar and then filtering the line chart. And if you know anything about table calculations and filter actions, if you're using a filter action, it's going to remove data from the view. So you have to do something different if you want to be able to show some sort of comparison data. So that's another piece to think about. And then you need to count the marks. And I love this pie chart here, though this one's a little better at explaining what I mean here. So this pie chart, that might be an ultimate goal of a visualization, and then actually in the viz I just showed you, is the Tableau Forms post I just showed you, I think this is probably where it's going to end up, but we're taking thousands of records, thousands of customers, and we're putting them together, getting them together, and the desired view just has 2 marks in it. And that's a really important thing. So what I call that is the granularity of the display. So it's the number of marks that are actually needed to draw your view. And you may not be able to exactly know it, but you can at least get within an order of magnitude or even closer of how many marks you ultimately need in that view. So understand your goal. What is it you're after here? The next piece is understanding your data. So we have our goal, which might be this pie chart with 2 marks. Then there's the grain of our data, which is what makes a unique record in that data set. So this is the foundational thing that we're working from. So I'm going to show you a quick example of that. If you were at my Boston Tableau user group presentation, you will recognize this piece. So here we have a data set. It draws from some real data. It's showing the number of cases of C. difficile, which is this nasty intestinal bug that people can pick up when you're in hospitals, and then the number of patient days, the number of days a patient was in the hospital. And then we have our columns here for each month, and then a separate grouping for each year, stuff like that. So if we try to bring this data into Tableau, and I'm not even going to try it, it's going to horribly break. We've got merged columns here. We're going to see lots of F1, F2, F3 stuff in there. It's just not going to work. So maybe we've learned a little bit about how, and this is a key difference between working with Excel and working with Tableau, is that Excel is really about formatting. Everything we're seeing here right on our home ribbon, this is all about formatting what we're seeing to make it look good, and we're able to merge cells together and everything. And Tableau is fundamentally a database-backed application. So it may be able to work with Excel data or text files, but fundamentally it's thinking about the world as databases do, where columns are fields in our data. They're defining attributes of our data, and each new row is a separate record of our data. So maybe we've learned some of this stuff and everything, and we transform the data a little bit, so we at least get all our years and our units together, so we've gotten rid of those fields, but we still have a separate column for all this. Now we can go back into Tableau with this and bring this data into Tableau, and we're seeing all these different things here. And we can try dragging them out and doing this now, and like, oh, I didn't need the sum, maybe you need to change it to dimension or something. What the hell is that thing going? This is not the experience of Tableau that we see in the Tableau demos. It's just not working right. And the reason why here, as we go back to Excel, as we're looking at our data, is that we've mixed up 2 different elements of our fields. So this is something to know about Tableau. And is that, in terms of thinking about feedback and how we get feedback. So when we're learning to walk, we get really awesome feedback as we're learning to walk, because no matter where we are on the planet, gravity works at 9.8 meters per second squared. So every time we move in the wrong way, boom, we fall over, and we learn from that. It's really consistent. Tableau doesn't necessarily give those nice messages once embedded data. It's hard to work with. So one thing to look at is if a view is hard to build in Tableau, look at the structure of your data. Maybe you're mixing things up a bit. So back here, in this Excel data set, what we've done here is we've taken these categorical elements of our data, because if we really think about what a unique record is here, and I've written it out, I often, for me, is kind of a verbal person that helps me write things down. So a record is really the number of infections, number of patient days, rate of infection per 1,000 patient days for each unit in month. So that number of infections, the rate of infection are really these quantitative fields, the things we're counting up, and then the stuff after for each, the hospital unit in the month, are these qualitative or categorical fields. So they're separating our data and identifying what is a unique row here. So going back to the cell data, as we're looking at it, we can see we've really mixed this up. So we have these categorical fields of our month are spread across multiple columns of the data, whereas we'd want them to be records. And then we have the things that we actually want to count, our measures, are spread across rows of the data. So in that, we need to transform it, and we can use something like the Tableau data reshaper or things like that to get there to something that looks more like this. And then with that data set, let's go back into Tableau here. I can do a new worksheet. I've already added it here. Here's my unit already. I can bring that measure data up there. Put all the months of data in here, and then the number of new cases, number of patient days. I'm into that drag and drop kind of thing that I can do with Tableau. It's really easy if I want to do like, okay, how many cases did I have over time, and do a quick table calculation on it. There I am. So the shape of our data is really important, and I think of it in terms of the Goldilocks metaphor. We can have data that's too wide, data that's too tall, or data that's just right, where we have enough of the categorical attributes and measures that we need. And one thing to know is that we can't make the granularity of our view or what we're working with in Tableau any finer than what's in the data. There's a little caveat to that we'll talk about later. So sometimes that's where we need to reshape our data to make it taller. So the next piece is the structure of our data. What are the relationships in our data? So here we might have a view with department. So we're getting 3 marks down here. I use the marks, the status bar a lot for this, to see this. And then we bring in region, or look at region here. So we've got 4 regions. We put the 2 together. I'm now seeing 12 marks. There's a region for every department and a department for every region. It's a many-to-many relationship. Let's say we're looking at just category, and I look at where there's 17 marks down here, and I put in department and category. Now we're looking at still only 17 marks. So what's going on here? So we're looking at a table, and this is one of the ways I'll look at unfamiliar data sets to check them out, is to just do this kind of thing. So I have department and category here. In this view, I can see, well, maybe it's kind of hard to look at. Let me go this way. Oh, look, each category only has 1 department. So there's a one-to-many relationship between department and category. And in fact, with that kind of relationship, I can now aggregate department, and I haven't changed the view at all. Right here, whereas if I go back the other way and I aggregate category in some way, like I do a minimum category, I'm only getting the first category in each department. So understanding the relationships between the fields in our data is necessary to determine what's going to happen as we're starting to aggregate our data and ultimately use table calculations. And then the next piece is the sparseness of our data, so how that is. So back in Tableau here. So here's one way Tableau shows sparseness of our data. Everywhere there's an ABC here, there are 1 or more records in the data with this combination of dimensions. So we can see there's a hole here, right, where there's no jumbo box or office supplies. And can you guys still hear me? There's a lot of background noise. Oh, gone away. Okay. So in this view, this is something where I have category and year sitting here, and the data is actually sparse, but it's hard to tell just by scanning down it what's going on. So one of the ways I'll do is I'm looking at it, is I'll do something like do a count distinct on it. And this can be hard to see, so if I put it on columns, now it's easy to look down and go, okay, of the 4 years in my data, envelopes doesn't have as many, or office furnishings doesn't have as many years in them. Another place you can also do is put something on color, and then the color legend is giving you an extra bit of information about what things are happening there. So it's another way of kind of interrogating the data to understand what's sparse or what's not. Because if we're expecting there to be every year for every category in our calculations and then one's missing, we're going to end up with not the results we expected. So those are foundational elements in understanding in data. The next piece here is understanding Tableau. So all these different factors here. And we don't have too many of them. So one of the things to know here is we're working with Tableau. It may seem hard to understand, but there's actually a logic to what Tableau is doing here. And I'm just getting it to my notes here. And with that underlying logic, we can figure it out. So this is something I put together by figuring out all this stuff out. So it is possible to do that. So in some of these factors, I'm going to quickly go through a few of them. So one of them is the 4 pill types. Hopefully this is new to you. So the 4 pill types are the combinations of continuous and discrete dimensions and measures. And we will quickly see those in Tableau. So I can have sum of sales out here. This is a continuous measure, continuous because it's green, and I can see it's an aggregation from the sum. And I can see sum sales with region. So I have a dimension here, which is a discrete dimension because it's blue. And then sum of sales, and then I can even have sum of sales be in the view as a discrete measure and in the view as a continuous measure. And if I want to, I can even go to all of them in the same view. So I can have sum of sales as a discrete measure, sum of sales as a discrete dimension, and then as a continuous measure and continuous dimension. So what we see here on the left is just Tableau's initial assignment of dimensions and measures, where Tableau is trying to identify what are the categorical fields in our data, what are the quantitative fields in our data. We can move those around as we need to, and then in the view we can convert them around as we have to. So some other things with 4 pill types here. For time, I'm going to zoom through this. Key thing with continuous is that you're creating axes and additional marks cards, whereas discrete pills are going to create headers and pins in the view. For dimensions and measures, this is where it's really at when it comes to table calculations. So dimensions, like I said, they're categorizing your data. The dimensions are determining what makes a mark in your view, and I'm going to talk about that in a minute here. And the key thing for table calculations is dimensions of what are partitioning data for your table calculations and what you're addressing over for your table calculations. In Tableau, we don't sort measures, we're actually sorting dimensions by measures. So dimensions do all this stuff. Measures, their value is some sort of aggregation depending on what the dimensions are in the view in your data. That's pretty much it. And there's one special case where we can use ignore it in table calculations as an option on the pill to add a discrete measure to the partitioning of table calculations. So that's a quickie on dimensions and measures. Now we're going to talk about the green of the data and the green of the view. So in our data, in this batch of Superstore sales I have, there are 9,426 records. If I put department in the view now here, department is causing the view to measure some number of records to be grouped by department. So the view is being, the number of marks, these 3 marks are being determined by department being in the view, and then it happens if it's on rows, on columns. If it's on pages, we see 1 mark at a time, but I can click through them, 1, 2, 3, and they're there. If I put department on the level of detail, we still see 3 marks here. And everything, the one place where a dimension does not increase the granularity of the view is on the filter shelf. So if I put it here. So, and then if we add additional dimensions, like I've added categories, so the view is now at the granularity of department and category, but because of the one-to-many relationship between them, this goes back to the relationships between the data, department is not actually increasing the granularity of the view, whereas if I bring in, for example, order date, then that's increasing the granularity of the view. So the granularity of the view is the distinct combination of values of the dimensions in the view. So one thing that very often trips people up as they're working with table calculations is maybe they're thinking like, okay, well, I have this view for category in it, or maybe I have each category, and then I want to show each item that somebody purchased from within that category in my view. So I'm going to bring category out here, and I'm just going to stick it on the level detail shelf for the tooltip. And then they're like, what the hell happened here? So item is part of the granularity of the view. So having this understanding is extremely important, because if we have a table calculation like a percent of total sales or something like that, that's now going to be affected by the item dimension in the view. But this isn't all with this kind of thing. So here I have a simple scatter plot, some profit on columns, some profit sales on rows and department here. And then I can duplicate that marks card, in which case both marks cards still have department on here, only I can change this marks card to have category on it, for example. So now I have two different continuous pills here, creating two different axes. Each axis gets its own marks card, and each marks card can have its own completely different level of detail. So, and then I could do this by order date if I wanted. So the order date for this marks card, or sorry, the granularity of this marks card is order date and department. The granularity of this marks card is order date and category. And then we can go even further with it if we want to, and I won't cover this today, but we can actually have blends at different levels of detail coming from these different marks cards that were there. So it's pretty neat what we can do with that, and that's something to be aware of. So this real part of the green of the view is that it's the dimensions in the view for each marks card that you have in the view. So it's one way to kind of end up seeming to get a bit more granularity than what you have in your raw data, because you can add to your view that way. Here's another example of this. I have a basic map here with state as a filled map, and then I can add another latitude pill here and change this. So this pill is actually the level of detail of city. So the state marks are colored by the sum of sales, and the city marks are colored by the sum of profit. So a different level of granularity, different aggregations happening in each. Records to marks, to talk about that a little bit. So I already talked some about how Tableau turns records into marks here. We're talking about how it aggregates measures in the view. Another way Tableau can turn records into marks is with the convenience dimension and measure names and measure values. So if I take sum of sales here, add discount into the view, Tableau has now taken these two measure values, grouped them into one measure, and I'm putting measure in air quotes here, and then there's this dimension measure names, which is added to the view. So I've increased the granularity of the view. So if I have a new worksheet here and I can bring out my lowest level of granularity, the row ID in the view, and let me move these down so I get a little more room. I have my sum of sales here, so now I'm seeing I have 426 marks, and then I bring out discount into the view. I'm seeing 18,852 marks. I've doubled the number of marks from the same number of records. So in this way, measure names is in essence kind of unpivoting the data to make it even taller in a way. So I have each measure as a dimensional value, and that dimension being the measure name. So that's records to marks, 3 levels of calculation. So we have three levels of calculation in Tableau. There's row or record level. So there's a result computed for each record before aggregation. So this is happening at the grain of your data. Then there's an aggregate calculation, which is computed at the level of detail of your view or marks card. So at the grain of your view, and all aggregates are measures. And then there's table calculations, and table calculations can be run along different ways in our views and be nested up to 128 levels deep. That's thanks to Noah Salvatierra and Richard Keefe for doing the crazy work to figure that one out. So a quick example of this, kind of the archetypal example, is let's say we're in category and we want to show the profit margin for each category. So we create a calculated field with profit over sales. I did this first time in Tableau, most people do. And then we dragged it into the view, and the profit margins are insanely huge. They just don't make sense if we sum up our sales and profit. Here, the profit margin should be quite a bit lower. So the thing we need to do is use an aggregate calculation. So we're going to aggregate our profits as a level of detail of our view, aggregate our sales to the level of detail of our view, and then divide them. And that gives us an accurate profit margin. Now, here's another case of aggregation where we have to think about what level we're aggregating at. So if I have my profit margin, and here I've just plotted it for binders and binders accessories. So this is totally accurate. And then if I do a quick table calculation of a moving average, so I'm going to look at 3-month running average of our profit margin and everything. So this is just averaging out that original profit margin number right here. So just this number, whereas to be a true average, we probably want to actually sum up the profit over those 3 months of time and sum up the profit over those 3 sales of time, and that will give us a more accurate moving average of those. So I have separate moving averages of each table calculation, then I'm dividing them to get an accurate result. And we can see the difference here if I turn this into a dual axis. And here's that moving average. That was the quick table calculation in the brown, and we can see these numbers are really huge here, whereas this profit margin is smoothed out and more accurate, showing the profit, the sum of profit over 3 months and the sum of sales over 3 months. So the 3 levels of calculation that we want to work with. And then another piece in here is the order of operations. So when does Tableau do things? So very quickly, Tableau, as soon as we're dropping a pill in the view, Tableau's querying our data sources, doing a lot of work in there, and I'll talk about what happens in there. It performs data densification, so there's a number of ways Tableau tries to be helpful in getting us what we not want when we have sparse data. Data blending occurs after data densification. Then Tableau applies filters on calculations that are using fields from secondary or primary sources, so multiple sources. Then it splits into 3 different paths. So there's computing table calculations in R scripts, grand totals is a separate path, and forecasting is yet another path that I might go in, and then Tableau puts that all together. Any mark hiding happens then. Also, table calculation filters are applied then. That was in the 3 paths. Adding in geocoding, linking up the view, finally drawing the marks. Inside the query, Tableau is doing a number of things. So top of the list is data source filters. They have precedence over everything else. Context filters are second. Top and conditional filters are third in that order of precedence. Then we're computing the row level calculations, which may be used in data source filters, context filters, or top and conditional filters. Then filters on dimensions are applied. The non-blended aggregates are applied, and then those filters are applied in the view. So there's an order of operations in here too about how we want to end up with things, which is very important when we want to think about, okay, what's the granularity of the view? Now I'm going to go super quick on addressing and partitioning. So here I have an index table calculation on department in year. And one thing, we're going fast here while I take a breath myself and a drink of water. is that I'm hoping this is recorded so that way you can look back at it, because there is a lot of information here. So I have index, the default compute using on this is table down. I can swap these back and forth, and that works fine. Then we can switch up to year here, and my table calculation results have changed. So what's going on here is that this compute using of table down or table across here is a relative, what's called a relative compute using. It's relative to the dimensions in the view and their arrangement. So if I change things out, so a way to fix that is to specifically set the compute using. So if I set it on department, we're computing along addressing along department, so we're computing a value for each department and then partitioning on the year. And then we can set the compute using the year. And then if I do this, those results, furniture gets 1, office supplies gets 2, technology gets 3, are invariant to the pill arrangement. I can even put year down here, and I'm going to get the same arrangement of it. So that's a fixed compute using versus a relative compute using. Another piece here as we're addressing is with the sorting. I'm going to switch over to an advanced compute using. So we have two kinds of sorts here. There's an automatic sort, which is going to be using the sort on the pills in the view. And then there's a field, or what I call a custom sort, where all of our addressing pills are put together in the equivalent of a combined field, or an old Tableau set if you're pre-8.0. And then we can sort that by some measure as we want to get different results. So there's two different kinds of sorts we can do in the view. Then we have the restarting every, so I can do department and year. I can choose to sort this on something else, like my order ID if I want, and then I can set the partitioning. So even though I'm addressing on everything, on all the pills and dimensions in the view, I can choose to restart on some of them. I'm not going to talk about at the level today, because that would just take too much time. Just a super quick introduction to addressing and partitioning. One piece I didn't say here, dimension is not part of addressing or automatically added partitioning. This is something I kind of mentioned earlier. So let's say we have this one here of department and year. Let's just compute using department on this. And then if I bring something else like region into the view, actually I'll do a different one here for that. I'll take region off. Compute using, it's kind of easier to see if we have sparse data, so let's use continuous container on here. Okay. Table down, department container. That's not going to work. Okay. So I'm having a little brain fry here. So if I bring this into here, this view, here's one. My compute using was table down in this case. And what Tableau did is with my compute using of table down, that's going to take all the dimensions on rows and put them into the addressing. So it automatically added that to the addressing. However, if I put year of order date on here, Tableau is adding that to the partitioning of the view. And if we hover over the pill here, Tableau will tell us this. Results are computed along departments, so that's telling us our addressing. For each is telling us our partitioning, what we're partitioning on. And if we edit the table calculation, this description also shows it. So it's a useful way of interrogating what's going on. And then at the level, ignoring table calculations and most densification behaviors are not documented. You'll, if you do a web search for Tableau and those, you will find things on them. So it's a quick introduction to a number of the different factors that affect table calculations. They might seem really simple, but the vast majority of problems that I end up helping people with on the Tableau forums involve those. There might be other parts of it, but those are key ones. So what are table calculations good for? When are they appropriate to use? So when we want to perform a calculation across marks in the view, like in the case of this kind of view right here, if we want to do something like, instead of this, a running sum of sales, across here we're looking across these different marks in the view, the marks being created by our dimensions in the view. When you need calculations at one level of granularity and then display at another, and we'll go through, hopefully I have time to go through an example of that, or when you want to apply a filter without affecting most of your calculation results, because table calculation filters are applied late in Tableau's pipeline. So disadvantages of table calculations, you got to know what you're doing to get good results. Another piece is all the necessary data needs to be sent to Tableau. So if you want to do some sort of calculation involving 1 million different dimensional values, Tableau is going to have to get 1 million records from the query. So that may be too slow. Another piece is table calculations are done all at once. So unlike maybe if we're working with Excel where we might need multiple spreadsheets to do this and then do an aggregation with something else, if we're doing those multiple levels of aggregation in Tableau, we have to deal with all that complexity all at once. So there's a number of different alternatives to using table calculations, so using aggregates of row-level calculations, data blends, reference lines, etc., all the way down to writing custom SQL, custom queries. So calculated fields. I'm going to go really quick through this one. So in calculated fields, I have set up an office supplies calculation here, which I'm going to want to use to do something with. It's a row level calculation, record level, saying if department is office supplies, then return sales. When I bring in the view, it's aggregated to this. So it's returning the sum of sales for office supplies and null for everything else. Part of how I can tell these are null, even though there's not anything showing in there, is I'm seeing 3 marks here and there are 3 departments. So that's one way. Another thing that we have to deal with is, let's say I want to show my order date in a title here on this view. So if I go to worksheet, show title, and then I'm like, okay, I'm going to go in here and I want to enter my order date and apply. Now I'm seeing this all thing, because what Tableau does is it only show a single value for a dimension in the title, or we end up seeing this all. There's a couple places where it can do other stuff, but that's basically it. So understanding this piece around text or titles and captions need to return the same value to every address in the view. So if we want to do something like what our max order date is, then an order date is a dimension in the view, then we need to do something like a table calculation. So in this case, it is window max of max order date. I'm going to set my compute using, in this case, just use a relative one of across and down. So it's going across every single dimension in this view. And then I can go to my title here and insert my table calculation, and there I'm seeing the maximum order date in the view. And then another piece here is building small calculations and putting them together later. So rather than building some hugely complicated table calculation, maybe you build your calculations in small steps and then edit them later to put them together. So building the workout view, step 5 here. So one piece is to write out the specific goal. And in this case, I'm using the goal that I'd done earlier, which is drawn from this particular Tableau forums post where somebody had written something and then there was a little bit back and forth on it, and ultimately you wanted a goal view that kind of looked like this kind of thing. So, so here's the steps to use. So we're going to create a new worksheet, and this is where I was wishing I had a bigger screen because I was going to make this smaller. Then we're going to put all our dimensions on rows with our partitioning dimensions on the left. Spelled that. And then as we're doing that, we're going to review the status bar and look at the number of marks and see if there's the ones we're getting. We're going to aggregate our unneeded dimensions. So minimizing the number of dimensions that we have in the view is really useful in working with table calculations. Then bringing our aggregate measures, putting discrete ones in the level of detail where we can see them in tooltips, or continuous measures on measuring these values, and then using grand totals where we need to help evaluate them. And again, reviewing the status bar, applying our filters, making sure everything works. So we're just doing this stepwise. And then with table calculations, added table calculations, see what it looks like, apply your addressing. And in general, I pretty much always apply fixed addressing to my table calculations. So that way, as I move things around later, I can trust the table calculation is still going to be computing over what I want it to. Review, sorry about that, the status bar and the values in the view. And also, as you're adding nested table calculations, verify the compute usings every time, because there may be something where you have thought you'd set something one way somewhere, and then you set it up differently separately. And it's really helpful there. And so you repeat that, adding table calculation one at a time, reviewing everything, merging your complex calculations when you're ready to, and again, going through your validation steps, and finally applying the table calculation filters. Because there may be, as you're adding table calculations, you might end up with densification behaviors that you don't want, and applying, if you're applying filters too soon, table calculation filters, you won't see that until it's too late. So I apply them there. Then when it comes time to build your final display view, duplicating that worksheet, removing the table calculation filters, because as we're moving the tills around, we might trigger densification. So we want to be able to see it. And then moving the tills that you were helper pills to get you going, moving those out of the view, validating, moving the pills where you finally want them to go, validating that, applying your table calculation filters, and then you're done. So I'm going to walk through a quick version of this. So in this case, the goal here was to show the average number of appointments for each day of the week by each hour of the day for all dates. And there was a problem in the data where the data was actually sparse. So for example, if we look at Monday at 8 a.m. here, we're seeing some 6 records, and just visually I can see there's no Monday between April 28th and May 12th. There's no Mondays between May 12th and June 2nd. So it's missing data. So one of the first things we had to do was turn on show missing values to pad out the data, which is padding it out for all the dates in here between the start and end date. So I end up with Sundays that weren't in the data. Then here's my workout view. So I have all my dimensions on rows, the partitioning dimensions, the weekday and the hour are on the left here. My addressing dimension, because I want to sum up over everything, is on the right. So I have, and then the filter calculation we'll ignore for now. So some number of records here is showing null, because some number of records is computed in the data source. Or in this case, it's actually returning nulls because this is all padded out data and there's nothing there. So here we can see the data. Zn, some number of records, is now zeroing out the nulls, and because of the padding that's taking place, we're getting to see all those zeros here. So we're seeing our records. Then there's the number of visits, and I have 2 calculations here. Very often, I'll create a calculation here, and I'm just like, okay, what do I mean? So this is the window average of the sum number of records across all the days that we have here. But the thing is, if I just duplicate this and put it into a view, and I just get rid of these things that I don't need, and I put the month, day, year on here, suddenly I have all these records I don't need. So in this case, for the computation to be accurate, the view needs to be at 1 granularity, but the ultimate display, where we just want to mark for each day, is at a different level of granularity. So that takes a little bit of extra work. here, so I'm using the if first equals 0, so I'm taking the first address in each partition, so the first MDY start date in each partition is going to return the window average of some number of records, and then everything else is returning null. So then I see my optimized calc, and I can scroll down here and validate that it's returning exactly the same as I want to in here. And then I can start building my view where I'm dragging the pills off, moving pills around, reapplying my filter calc on here, and I have a view showing this, and then I can also change it around if I want. So for example, I could put weekday on rows and have a view that lets me see everything here. And then it makes it a lot easier to see that, oh, Friday has a much lower count of records, or for some reason there's an appointment at Tuesday at 5 o'clock that there was nothing anywhere else. So we can see our outliers. So it's a quick way of working through this. And then just to review on so densification. Hello. There's a lot of different forms of densification that Tableau does. And Joe Mako has another Think Data Thursday where he talks about a few types of those. And this is something that Joe discovered on a really reliable way to turn off domain completion. So in my last minute here, I'll do a quick example of that. Let's go back to Superstore Sales, new worksheet. So for example, I have, let's do exact date, and I'll make it a discrete here. So there's all my days. I have each department. And then if I have a table calculation with a compute using on the order date, note there are 3353 marks down here. Suddenly my marks count jumped up to 4257 because Tableau has triggered domain completion for dates. And this only happens with, will not happen with an exact date of a date time pill, but it will happen with an exact date of an order date pill. So the way to do this is I'm going to duplicate my order date pill onto a, whoops, that's not duplicate. Let's go back here. So I have this on here. So I have the dimension that's causing this domain completion to happen. And I'm going to change this into an attribute. I'm going to aggregate it. And now I'm back to 3353 marks. So the key to triggering this kind of domain completion is a table calculation with a compute using on a date pill that is on columns, rows, or pages. I've just turned it off by putting it on the level of detail shelf. And if you're running into densification behaviors that you don't like, as you're tracking the number of marks in your view, you may need to move all your dimensions onto the level detail shelf and use only aggregations for it. So you might use adder, min, max, whatever, to get those. So with that, any questions?
Hey, Jonathan, that was great. Yeah, if there are any questions, anyone has their hand to leave, or I mean, have their hands up, I can open it up and unmute you at this time, or you can send a chat message as well.
So one question was, do you have any blog or posts that explain densification in more detail? My blog is drawingwithnumbers.artsarc.org. And if you look on here and if you do a search for densification, you will find a number of different things here on there, and I will send this out in the chat window to everybody. And then there's another piece here. As I mentioned, Joe Mako did a really nice Think Data Thursday. Think Data Thursday, Joe Mako on densification. And if you look in the Think Data Thursday group, and do a search for it, you'll find it somewhere down in here. Domain padding. What is the name of that one? Matt says, can we get access to some of the slides? I will be posting the slides on the Think Data Thursday group right after we're done here.
Awesome. Okay, and looks like there's a person that also posted a link to identification. I'll go ahead and add that to the Think Data Thursday email thread that we have in the groups as well. I guess with that, I will.
There's one more thing. Suzanne Carter said, we're only on slide 92. What are we missing? So it's just a bunch of draft slides from previous iterations of this, as well as more detail that I could not fit in the hour that we had. So there is a ton of material here. This is, let me go back to this view right here. A little self-plug here. This is what will be going in the book that Joe and I have been working on, and we already have a couple of hundred pages of material that goes into way more detail on this than you might ever want to know, or maybe you do really want to know. And then two other plugs. Joe is doing a session at the Tableau conference that is on the fundamentals of Tableau from his point of view, so it's kind of his spin on some of this stuff, and I think it'll be one of the best and most important sessions for people to go to at the conference. And then I'll also be doing a session on the conference that talks about how you can use this kind of knowledge of Tableau to do crazy, wacky things with data blending. So that's the end of the plugs.
Yeah, that's great. Well, thank you, Jonathan. I don't see any other questions, so I'll go ahead and start closing things up then. I have recorded the session, so we will go ahead and post the session up there later today. And thank you again.
All right, thank you.
Okay.
Yep, bye.
Bye.